In this video, we're going to be exploring simple equations and graphs of ellipses whose centers are at the origin. There are a few basic rules that we're going to follow. The equation for an ellipse looks roughly like this. And if we remember where the A and the B come from, the A is the length of half the length of the major axis, B is half the length of the minor axis. So when an ellipse is in this form, the square root of the number underneath the x squared term is going to give us the length of the major axis, half the length. The square root of what's in the denominator underneath the y is going to give us half the length of the minor axis, which is our b, and a is always bigger than b. The c comes into play when we use that formula, c squared equals a squared minus b squared, and c will tell us the location of the focus. And the thing is, when the larger number is underneath the x squared term, we know that it's going to be a horizontally graphed ellipse. Again, if this is our major axis, obviously it's going to be longer along the x-axis. If, however, we've got x squared over b squared plus y squared over a squared equals 1, and this is the larger number, the major axis number is always bigger, a is always bigger than b. If the larger number is underneath the y, we know that the major axis is occurring along the y-axis. Now we're really kind of getting a little tired, I think, of seeing some of these variables. So in the next screen we're going to be doing an example of how you might look at an equation for an ellipse and make a rough graph of it. Let's say you've been given the equation x squared over 25 plus y squared over 9 is equal to 1. And the first thing that you might want to determine is which of these is a or b. Well, a is always bigger than b, so we're going to realize that our equation is really in this form. What times itself gives you 25? A is going to be equal to 5. What times itself gives you 9? B equals 3. A rough sketch is going to look like this. Centered at the origin, a vertex is going to be at 5, 0, and another vertex is going to be at -5, 0. Where the minor axis intersects the ellipse, those points are going to be at 0, 3, and 0, -3. And if we wanted to make a very crude kind of drawing, that's a basic picture of this ellipse. If we were asked where the foci are, question mark, we would say c squared equals a squared minus b squared, 25 minus 9, 16, so c would be equal to 4. And we could plot that. Let's use a different color here. That length is going to be 4. The coordinates of this focus are going to be 4, 0, and of this one, -4, 0. What if someone gives us this equation for an ellipse and asks us to draw a rough sketch? The first thing that we notice here is that the number underneath the y squared is the bigger. The major axis is going to be occurring along the y-axis. This is going to be a squared. This other number is going to be b squared. So now we can just do a rough little sketch. Since the major axis is going to be this distance here, from here to here, is going to be 6. We could say the whole major axis is length of 12, but this is really all we need to label this point. We could say the coordinates of this point, the vertices on this ellipse are going to be 0, 6 and 0, -6. When we see what B is, that's going to be the distance, half the distance of the minor axis, and we realize that that's going to be at the point 2, 0, because 2 squared gives us 4, and -2, 0. So whichever variable has the larger number underneath it is going to be the one that has the major axis. The only thing that we need now is to calculate what C is, so that we could locate the coordinates of the focus. A squared minus B squared, 36 minus 16, 20. C is going to be equal to the square root of 20. I would typically turn that into a decimal number so that I could actually locate it on a graph. Please excuse. It's not 36 minus 16, of course, it's 36 minus 4. These numbers are already squared. So here we would have the square root of 32. Now again, I was right in saying that I'd rather write that as a decimal number. I guess I would round that to 5.7, and that would allow me to label where the foci are, and this focus would be at 0, 5.7, and this focus would be at 0, -5.7. As just kind of a final summary, what you're going to be doing first when you look at an equation for an ellipse is to compare these two numbers. The larger number is going to be underneath the variable which is going to represent the major axis. So in this one, you're going to have a major axis along the y-axis, and this length here, taking the square root of 100, which gives you 10, will give you the location of the vertices. The minor axis, the square root of this will give you 7, and that will help you locate where the minor axis intersects the ellipse, and again just a rough sketch, and then you can find where the focus would be, the two foci would be, using c squared equals, this is now going to be a squared minus b squared, and you'll get the square root of 51, which is a little bit bigger than 7. We could round that to 7.2. So the focus here is going to be at 0, 7.2, and this focus is going to be located at 0, -7.2. Now looking at this one, again, our first step here is always comparing these two numbers. Here the number under the x squared is the larger. We take the square root of that to find half the length of the major axis. So our first step here is to realize that it's going to be, this is going to be the major axis, and this distance here is going to be 4, or the square root of 16. This distance here is going to be the square root of 4, or 2. You can label these points if you'd like, but we're just writing the distances on here. And then the distance from the focus to the center can be obtained by using this formula, and it's always the larger number squared minus the smaller number squared. We get c equals the square root of 12, or approximately 3.5, so this point would be at -3.50. This point would be at positive 3.50. And I think one just general key will be to just make sure when you're done that your foci are inside of the ellipse. I think if you make a mistake, they might end up somewhere else. This is just a real quick introduction to writing, drawing graphs from equations of ellipses which are centered over the origin.